All right. Hi, folks. This is Ying from IBM, sending greetings to you from China. It's my pleasure today to talk about the Presto native Iceberg support at VLOXCon today. So in my talk today, I'll first briefly go over what Iceberg is and why do we need it. And then we'll talk about our goals and the status of the project and what progress we have made so far. And then we'll talk about the design implementation, followed by some preliminary performance numbers. And then we'll discuss the future work. So what is Iceberg anyways? So as many of you have known, Iceberg is a very popular table format. And what is a table format? So in my understanding, so it's essentially a specification saying how we manage all the data in a table over time. So as we know that the traditional Hive tables manages the data by directories. And you have to, list all the directories and list all the files within that directory in order to know what data you need to read for that particular table. And the update support is very poorly for the Hive tables. So for example, you're not able to do row level inserts, deletes very efficiently on the Hive tables. And even more on the closed Hive partitions, you're not able to do any updates at all. Also, there was no way for you to do like concurrent updates to your data safely. And in addition, it doesn't do well for handling the evolution of the schema and data. So Iceberg was born to solve these problems. So with the design of Iceberg, users can do very efficient small updates like row level inserts, deletes, and upserts, and so on. And all these updates were fully with ACID guarantee. It supports snapshot isolation so that all your updates can be isolated very safely. It supports time travel so that you can go back to a certain time in history and check the data at that time point. And all these design bears in mind of the performance requirements. A very good thing about Iceberg is that it manages the table using a set of files, the metadata files and the data files, so that we don't have to do expensive directory listings and file listings. And all the lists of the files were defined at the right time in the manifest file. So we only need to read that the relevant manifest file to get all the locations for all the data files that we need to read. And it also designed to hold more complete column statistics so that the files can be eliminated efficiently. So the changes like insertions, deletions are now made at the file level instead of the whole partition level in Hive. So with the last few months, we have been working on support Iceberg in Prestissimo. So our goal is to support the full functionality of Iceberg, including read and write. So, but we started with the read support. So far, we're able to read all the Iceberg V1 tables, no matter it's partitioned or non-partitioned tables. And in addition to the data columns, the user can query Iceberg specific metadata columns like data sequence number and path, and also some metadata tables like properties, histories, snapshots, manifests, and change logs. And for the Iceberg v2 tables, which includes deletes, so now we have already supported the positional deletes, and equality deletes was already implemented, but the reviewing is still ongoing. But internally, our tests has shown that the data with equality deletes works fine for all the TPCDS and TPCH queries. And we have already supported time travel. So users can directly call the system function rollback to snapshot, or the select query with the as of clause of importing snapshot ID or a timestamp. And we have also built in some caching support, for example, the manifest file caching, so that getting the metadata of a table doesn't have to be, go through the expensive, relatively expensive Iceberg APIs. And in addition, we made a bunch of bug fixes on existing Iceberg connectors. And on the table management side, in addition to the already existing create table and create schema or drop table, drop schema support, we now support create and drop views and truncate table. And our optimizer team has been very diligently working on stats collection for Iceberg connector. So as you know that Iceberg would collect additional statistics in the manifest and also related pathing files. So far we have supported table sampling and distinctive values, and also supports better or more precise data size estimations. And for the tests, we have introduced the Iceberg external worker query runner. So users are welcome to use it to try creating Iceberg tables and inserting some rows, and select from the Iceberg tables and try the time travel queries as well. And we also built in the TPCH and TPCDS end-to-end tests, which includes not only the power phase, which is the read-only queries, but also the data maintenance phase. So those data maintenance tests comprise of insertion tests and then deletion tests. And we have tried both positional and equality deletes, and the tests all pass for those for all the queries in these benchmarks. And now we're doing like larger scale testing of 1 terabyte and 10 terabyte with the full-fledged of functionalities, including insertions and deletions, and the retest after these data maintenance tests. So now let's talk about how the Iceberg read work. So on the procedural coordinator, the planner needs to ask the Iceberg catalog to get all the pointer to that manifest the metadata files from the Iceberg catalog. And specifically, we implemented a special rule for Iceberg filter pushdown, because for vlogs, the filter is required to be pushed down to the readers. But in Presto Java engine, the Parquet reader there doesn't support the filter pushdown. So the users will need to turn on a session flag, session property to enable the Iceberg filter pushdown. And then the scheduler would rely on the Iceberg library to do scan planning, which it will create a scan task, which does the partition, the file pruning based on the statistics, and then return the Iceberg splits to the Presto scheduler. And then the scheduling process will send the splits to the workers. And for that, these splits and the related Iceberg objects will need to be serialized and deserialized by the Presto protocol. And then when the worker gets the Iceberg split, it will recognize that and then send to vlogs for additional processing. All right, so to make the vlogs processing work, we have introduced the Iceberg split reader, which is a subclass of the split reader that specifically handle Iceberg splits. So we identify the Iceberg splits by checking the custom split info in the Hive split. When it's a Hive Iceberg, then Iceberg split reader will be created. So there are two very important functions. So one is the prepare split, in which the split reader would create the row reader, the reader and the row reader. And then for positional deletes, it will create the positional delete file readers and call the read delete positions on these positional delete file readers. Oh, sorry. So these this should be reversed. So this should be a positional delete file reader, and this one is the row reader. And then this would return a delete bitmap and be wrapped in the mutation object and then passed to the row reader's next function. And so then these delete bitmaps would then be applied to the initial row sets of the column readers. And then the results would be returned by get values. And this is the same for Hive, so I'm not introducing it here anymore. For equality deletes, we just have the equality delete file reader, but the major work is done in the prepare split function, in which we'll read the equality delete files and create either subfield filters or some expressions to be further evaluated by the Hive data source. And we have done some simple V1 table read performance tests, and we have shown that it's about 2.36 times improvements over the Presto Java implementation. And now we're doing benchmarks on the V2 reads, but our data is still need to be loaded. So the result is not ready yet, but we'll get it soon. And for future work, there are a bunch of optimizations we want to do on vlog side. And on the coordinator side, we will do some better caching support, and more statistics and cardinality estimation implementations. And in the next step, we're going to implement deletes. So we will be able to write delete files using the native Presto, which includes the positional delete and equality deletes. And this involves more general plan change, and we'll do it next step. And insertions should work by now, but we'll need to better test it. And there are many other things that's Iceberg specific. For example, the compactions and data cleaning. Like we want to clean up the snapshots that are no longer used, and we want to compact the small files that insertions and deletions generated. So all these are very complex and important work to do. And last, I like to present our team. So we are a team from community. So most of us are from IBM, and they're also very active community contributors from other companies. And I would also like to thank Jimmy and Xiaoxuan for reviewing our PRs. Many thanks. So that's the end of my presentation. So my colleagues will be really happy to answer the questions you might have. Right? Thank you.